All right, exponential, moving back into exponential and logarithms. By the way, how much we get done this week probably determines whether we have to come next week or not. So I'll talk about that at the end, but we'll go ahead and get moving on this. I don't want to do too much, but there's not very many topics in these last three modules. So you only got three new modules and you're done. This one's just using the calculator. So just make sure you use parentheses, close the parentheses. To the exponent button is this one right here. So you can do to the 1.8 and you get your answer there. Not really any trick right here. Probably just, y'all probably know how to use the calculator. Nothing fancy there. Just that's the exponent button. Make sure you use parentheses where they are. That one shouldn't be too difficult. All right, solving an equation of log base. Oh, it didn't go to it. Solving logarithm equations to start. This is kind of the way I do logarithms. You already kind of solved the equation. Log 49x to the 1/2. So it should look kind of familiar to you because this is the way that I kind of teach logarithms with the equations. But what it's going to do is it is going to switch up where the variable is. Okay, so this is saying, we got a hard one to start, but that's fine. This is saying you may realize what logarithm's doing, but what you want to do here is always change it back to exponential because that's going to make more sense in our head and to look at it like that. So this is base 49. The exponent is always up here over there by itself because it's up there by itself, and this equals x. So 49 to the 1/2. What does the 1/2 mean? 49 to the 1/2. Anything to the 1/2 power means what? Square root. Okay, so that's saying what number 2 times itself is x. So my answer here is 7. Okay. So I always want to rewrite to exponential, and that's going to really help you solve the problem. Let me see. Oops, how much they switched the x there. X 1 over 49 too. Why are they going to keep giving me 49? That one seems a little different. Okay, so on this one, again, it's hard to look at it and figure out exactly what you're doing. So if you want to rewrite it as a base, it'd be base x to the second power is 1 over 49. Okay. So my exponent is positive, so it's not going to drop down. So you saw me click solve right there, so you saw the answer. But what you're looking at here would be what number squared is 1 over 49? Well, 1 squared would be 1. 7 squared would be 49. So 1 over 7 would be my x. What you can do technically is do some algebra and do the square root of both sides, right? That'd be the square root of 1 and the square root of 49. And you get x equals positive 1 over 7. When you do the square root inside of equation, you usually put plus or minus, but logarithms always have to be greater than 0. It's not even just a positive, but they have to be, or greater than or equal to 0. They actually have to be greater than 0. I'm just trying to see if we get some different variations here. That's kind of the same thing as we did on the first one. That's the same thing as the second one. Let's look at this one. Log 6 x2. Log base 6 of x equals 2. All right. So on this one, we do base 6. The exponent's up over there by itself. So 6 squared equals, I wrote the answer. 6 squared equals x. So x would be 36. This is what a log is saying. 6 to what power is this number? I guess this is saying this. But you got to figure out how to rewrite these. So just change them to exponential, and then you can kind of see what to do from there. So my base is the little guy, the exponent is over here by itself, and then this answer is on this side. And you've got to figure out, I told you the other day that knowing how to do that very well is going to help you do these logarithms, make them so much easier, is being able to go back and forth between logarithm and exponential. Log 3, 2x minus 6, 2. All right, so these get a little more complicated, but the process is going to be the same. You still want to just rewrite it to exponential. So this is going to be 3 squared. My base 3, my exponent's over here by itself, equals 2x minus 6. And once you do that, you can probably work it out from there. 3 squared is 9, 2x minus 6. So you add 6 to both sides, divide by 2. So x is 15 over 2. Nothing really tricky on these too much. I don't think there'll be any really crazy variation from that right there. But you just rewrite it to exponential and then you solve the problem. I'll do one more just because. 2, negative 3x plus 5, 3. All right, on this one, base 2, exponent's over here by itself, negative 3x plus 5. So 2 cubed would be 8, negative 3x plus 5. Subtract 5 would be 3. Divide by negative 3, and I get negative 1 equals x. That doesn't seem right. Yeah, it is. By the way, you should always take these and plug them back in and check your answer. And you don't always have to like fully plug it back in. But what you want to do is make sure that this right here is going to be positive, because you can never do the logarithm of a negative number or 0. Okay. So if I plug this one back in, all I really need to do is negative 3 times negative 1 plus 5. And that would be 3 plus 5 is 8. Okay. So that, since that is positive, we're okay. But if you ever plug it back in and you get a negative there, then that's not good. And I do not know for sure if they'll give you one of those. But how do I say this fast? Whatever you are taking the log of has to be greater than 0. So like this part in the parentheses always has to be greater than 0. So if this number is ever negative, you know it's automatically like no solution, because that can't happen. I was trying to see if they gave us any no solution ones. Oh, they don't have the option of no solution right here, so I don't think these give you no solution ones. Next topic might. Did I not put any? Oh, I feel like I should have put one of those in there. So here's another one. What you want to do on this, 6, 3, negative 4x, 9. So this is the next topic, problem type 2, very similar. Nothing really changes on these. You still want to, sorry, I'm kind of confused. I didn't put that one type of problem in here. Y'all probably don't want me to add anything to this class, all right? Oh man, I keep going, click on my email on accident. Negative 4x equals 9. All right, what you want to do is first, before you want to get the log by itself, okay? And the problem that I didn't put in here is you want to make sure you, sorry, I went blank. Combine logs, like if it's a problem that has multiple logs in it, you combine them using those properties that we talked about. So the first thing you want to do is get the log by itself. So I'm going to subtract 6 from both sides. So I have log base 3 of negative 4x equals 3. Now we are going to rewrite it in exponential. Okay. And now it's just like the problems that we did previously. Like all you got to do is get the log by itself first. So it's base 3 to the third power equals negative 4x. That would be 27 equals negative 4x. Divide by negative 4. So it'd be negative 27 over 4 equals x. And that does okay. You can get a negative answer because negative 4 times negative 27 over 4 would be positive 27. So that is greater than 0. We're good. Negative times a negative. That's all you got to really check those. Like, okay, this is going to turn positive because negative times a negative. So all you do on this one is you got to get log by itself, and then it turns right into like the other problems. We'll see if there's a different variation here, but I think it'll just be like you add that over or subtract it over. So there you subtract the 7 and then write it in exponential. Here you add 7 and rewrite it in exponential. Here you add 4 and rewrite it in exponential. I don't think there's, oh, here you divide by 6. I guess this is a different one. We can do this one. 6, 4, 19, 12. 6 log base 4, x plus 19 equals 12. So on this one, you're doing 6 times log base 4. So to get the log by itself, I divide both sides by 6. So I have log base 4 of x plus 19 equals 2. And then again, just like I said before, once you do this, it's the same as the previous topic. Base 4 to the second power is equal to x plus 19. x4 squared is 16. Subtract 19. Oh, I got negative 3. Is that bad? So let's check. If I plug in negative 3 back in, I get positive 16. That's greater than 0, so we're good. You can plug it back in and check it all the way out, but you definitely don't have to. As long as that's positive, it should work. Oops, sorry. Hit the wrong button. What's next? All right, this is kind of the same idea. Oh, there's one with 2. Let's do that one. But it's natural logarithms, x plus 1, 3. This is going to be, there is no difference between ln and log. You can still do all the same properties. I have no idea. I don't remember. 4x plus 1, 3. That's way off. ln 4 plus ln x plus 1, 3. You can still, no matter if it's ln or log, ln is still a log. It's just a natural log. Remember, that's base E. So you can work this the same exact way we've been doing. Like I said, you want to combine your logarithms. You always get it down to a single logarithm first. So when I combine these, you see plus, that's going to think multiply. So I'm going to do 4, I'm going to do 4 times this, which is going to be a distributive property. So it's the ln of 4x plus 4 equals 3. Sorry, I got to go see the answer real quick. I guess I could have read the directions. Okay, now that I have one ln and it's by itself, I can write it as exponential. Same steps as before. You get it down to a single logarithm, and then you change it to exponential. So this is base E. This is base E. So this is e to the third equals 4x plus 4. You'll have to do e to the third in the calculator. I'm going to just go ahead and work it out, kind of. So you would subtract 4 from both sides. So you have e to the third minus 4, and then divide by 4. So you have e to the third minus 4 divided by 4. You can work it out like that. Just kind of keep it as a variable and then go put it in the calculator. What did they say the answer was? Like 4.07? 4.02. It's like you do write it as a decimal. You can kind of work it out as a decimal too. Like you could do, what do we do? E3 minus 4 divided by 4. So you can work it out as a variable, and like I did, e to the third minus 4. I should have done my division bar first. I can't do that on the iPad. E to the third, come on, minus 4 divided by 4. So you can do it like that and get your answer, or you can work it out as a decimal. You can just do e to the third and do 20.8. Okay, then I'm going to subtract 4 from both sides. Then I'm going to divide by 4. And you still get the same answer. So you can change it to decimal first if you want to. On those, you're just going to divide by 3. I guess I didn't do one like that, so I can do it real quick. Oh, man, now I can't get back to one. 2 ln 3x negative 4. Okay, on this one, divide by 2, right? Divide both sides by 2, so I get the ln of 3x equals negative 2. So this is, again, my base e right here. So this is e to the negative 2 equals 3x. And then to get the x by itself, divide both sides by 3. So e to the negative 2 over 3. I think it's easier just to leave it as an e and solve it, and then go to the calculator and put it in. I saw the answer, so I'm going to go ahead and write it. Then go to the calculator, because then you don't have to write a decimal around the decimal or anything. So e to the negative 2 divided by 3. E to the negative 2 divided by 3. So I think it's easier to do it that way, but if you want to work it out as a decimal first and do e to the negative 2, work out the problem, and then at the end you divide by 3, that's fine. Whatever way works for you. All right, exponential equations. 8, I don't want to start with that one. Yeah, that's fine. 27 equal 9x minus 5. All right, on this one, to solve an exponential equation, the first thing you want to do to see is can you manipulate to make the bases the same? Can you manipulate to make the bases the same? So what I mean by that is when I see 27 and 9, what's the first number that comes to your head? Like 3, right? So what if I change 27 to 3 cubed? 3 cubed is 27, right? And then what if I change 9 to 3 squared? Wouldn't that be the same thing as 27 and 9? But then I have this x minus 5 up here. But now my bases are the same, right? 3 cubed is 27, 3 squared is 9. Oh, I didn't change a number. I just rewrote it a different way. So what this allows me to do is say, since my bases are the same, my exponents have to be equal. And I can just solve the exponents. So you make the bases be the same, and then set the exponents equal to each other. So this is 3 equals 2x minus 10. Add 10, divide by 2. I'll write that up here. Bases are the same, so set exponents equal to each other. Let's do one more of those real quick. (64, 16, negative x minus 4). So on this topic, I believe all of them you'll be able to change to be the same. So what we're going to do here is 4 cubed is 64, and 4 squared is negative 16. I'm sorry, positive 16. 4 cubed is 64, 4 squared is 16. So now my bases are the same, and when the bases are the same, I'm going to go ahead and distribute this just to save a step. Be negative 2x plus or minus 8. Bases are the same, so you set the exponents equal to each other. Now I add 8 and divide by negative 2. Okay. So you manipulate it to kind of rewrite the bases in a different way to make the bases be the same, and then you can set the exponents equal to each other. To negative 4y 11. Why does that matter? We're going to see if we get the same answer. Oh, no. 2 negative 4x equals 3. Sorry, I just got to check one thing real quick. I don't really know why these are different topics, because I would just do them the same way every time. Trying to make things easier for you here. Yeah. Okay, so, oh, I didn't write that down. 2 negative 4x3. I completely forgot where the negative 4x is to the exponent. Okay, so you do this one, you have an exponent equation. Yeah, you know it's an exponent equation because my x is in the exponent. But what I'm trying to figure out here is how do I make 2 and 3 be the same base? Like previously I did, 4 cubed equals 64, 4 squared equals 16. But I can't make 2 and 3 have the same base. So there is no way to do this. What you want to do, and this one, if you look at the name of this topic right here, this one says uses logarithms, and this one says uses natural logarithms. I always use the natural logarithms. I don't really know what the point of using logs are. It does the same thing. It works the same way, but ln, I get to write 2 letters, and log, I get to write 3 letters. So I'm going to do the shorter one. So what you do here is they can't manipulate it to make it be the same base. So I'm going to write the ln in front of both of these. I'm going to write the ln in front of both of these. What that allows me to do is use my properties of logarithms and take this exponent and drop it down out in front. So this becomes negative 4x times the ln of 2 equals the ln of 3. Now what you have to realize too is the ln of 2 is one number. Like I cannot separate the 2 and the ln, okay? The ln of 2 is one number and the ln of 3 is one number. So this is negative 4x times the ln of 2. Now what I would do from here is I would, to get the x by itself, I'm going to need to get rid of the negative 4 and the ln of 2. Negative 4 and the ln of 2. And again, the only thing that Alex is going to do different on this topic is they're going to use log instead of ln, but it would still work the same way. Y'all saw me check the answer. So this gives me x by itself. So then I have negative ln of 3 divided by 4 ln of 2. This right here is called the exact answer, but we will go find the decimal answer too. That's fine. The decimal answer, we have the answer right here, negative 0.396. Okay. So now, once you get to that point and you solve for x, you would just plug it into the calculator. So you saw me plug it in right there. It was negative, but you just do negative ln 3 divided by 4 ln 2, and you get your answer. Well, they said round to the nearest hundred, so they put negative 0.40 for their answer. But that's fine. To do one more, 11x plus 8 equals 3. Oops. Okay, so again, I'm trying to get the x down here. To solve this, the first thing you always check is the bases. I can't make 11 and 3 have the same base. So on this one, I am going to take the ln of both sides. That allows me to take this exponent and drop it down out in front. So I have x plus 8 times the ln of 3. I'm sorry, the ln of 11 equals the ln of 3. I wonder how, sorry, I just wanted to see how Alex tells you to solve this. There's 2 different ways to do it. They would do it the easy way. Oh, look, another explanation is the ln. Okay, what I would do here is I would get rid of the ln of 11 first. Okay, you can distribute. That just takes an extra step. That's why Alex doesn't show it that way. So I have x plus 8 equals the ln of 3 over the ln of 11. And then to get x completely by itself, I subtract 8 from both sides. So I have ln of 3 divided by ln of 11 minus 8. And again, this is going to be my exact answer. And my decimal answer, I need to change that. I guess we can go to the calculator here real quick. I'll show you how to do it. Division, ln of 3 divided by ln of 11 minus 8. Negative 7.54. I thought there was a topic. I must have messed up the topics here a little bit because I keep getting confused. But I thought there was a topic that asked for your exact answer and then a different topic that asked for your decimal answer. We'll change that for next semester, but that is something that people do. This topic shouldn't be any different because, oh, it's that. Okay. EY minus 7 equals 4. This one is a little bit different. Okay, if you have an E in there, my goal is still to manipulate these if I can, which I can't because it's an E. So I need to drop this down. The way I drop that down is I'm going to take the ln of both sides. That allows me to take this and drop it down. So I have y minus 7 times the ln of E equals the ln of 4. Does anybody remember what the ln of E equals? The ln of E equals 1. It always equals 1 because the ln of base E to the E is what? Right? Ln is base E, so this would be E to what power is E? 1. Okay? So anytime you see the ln of E, you always put 1. That's what makes these super easy because that just goes away. If it's just 1, it's 1 times y minus 7, which is just y minus 7 equals ln of 4. So now I add 7 to both sides. Do not make this like ln of 11. These are separate numbers. This is its own little thing, okay? You cannot make that 7. You got to do the ln of 4 first. You got to do the ln of 4 first. What is my number? Y? Sorry. ln of 4 first, and then add 7 to it. So go back to the calculator for a second. I do the ln of 4, and then add 7 to it. So never separate that ln out from its number. That is its own little people group. Leave it alone. I guess I'll do that one real quick just because e to the negative 4x equals 8. Nothing's really going to change on this topic, though. You just do the ln of both sides. That allows us to drop this down. So that's negative 4x times the ln of E equals the ln of 8. Well, I know the ln of E equals 1. So this becomes negative 4x equals the ln of 8. Divide by negative 4. So x equals the ln of 8 divided by negative 4. Again, this is my exact answer. And then you find your decimal answer. Oh, I didn't find the I didn't write down the answer. I guess I can do it real quick. For the last one. ln of x plus 7. Sorry, I'm going to go write that answer down and write down the decimal answer. 8.39. What's the decimal answer for this one? Negative ln of 8 divided by 4. Negative 0.52. All right, so that does